Imagine you run an ice cream shop. Your goal as a business owner is to maximize profit. If the market price for an ice cream cone goes up, you have a strong economic incentive to produce and sell more of them. You might hire extra workers or buy another ice cream machine to meet that lucrative demand. This table is a supply schedule, showing how many cones Sung-yu is willing to produce at different prices. At $0, he produces nothing. As the price climbs to $1, $2, and $3, his quantity supplied rises to match. To visualize this behavior, we map this data onto a graph. Price always sits on the vertical y-axis, while quantity supplied sits on the horizontal x-axis. As we plot Sung-yu's table point by point, the pattern becomes obvious. By connecting these dots, we create the individual supply curve. Because higher prices lead to higher quantities produced, this line consistently slopes upward. Economists call this predictable behavior the law of supply. So, a single seller supply is driven by a direct, proportional relationship between price and quantity. As long as all other factors stay the same, a higher price will always yield an upward trajectory in production. Real markets aren't run by just one person. To understand market supply, we have to look at what happens when multiple sellers, each with their own distinct business costs and production schedules, compete in the same space. Let's introduce a second ice cream seller, Donghyun. This chart derives total market supply. The critical methodology is isolating a specific price point and adding the quantities horizontally. Look at the $4 row. Sung-yu produces 3, and Donghyun produces 4. Adding those horizontally gives a market supply of 7. Take a second to look at the next row. If the market price rises to $5, what is the new total market supply? Sung-yu supplies 4. Donghyun supplies 6, giving us a new market total of 10 cones. Market supply is simply the horizontal aggregation of every individual seller's volume at any given price tier. Now we hit the most common academic trap students face when studying supply mechanics, confusing a change in quantity supplied with a change in supply. They sound similar, but they describe two entirely different market events. When only the price of the ice cream changes, the supply curve itself does not move. The line is static. We are merely sliding up or down along that existing track to find the new quantity. This is a change in quantity supplied. Look at this graph showing 3 separate supply curves. When external factors change, the baseline curve physically shifts. Left and right movement indicates true supply changes. Cheaper ingredients, better technology, or more sellers shift the curve right. Rising costs or negative expectations pull it left. Think of the actual price of the good as a slider moving along a track. External market factors, on the other hand, pick up the entire track and move it. Let's apply this logic to a final scenario. Imagine summer is approaching, and 5 brand new ice cream shop owners open for business in the same neighborhood. How does this visually affect our market graph? Because the number of sellers is an external variable, the total market volume expands regardless of the current price of a cone. We have more businesses producing goods, forcing a definitive rightward shift of the entire supply curve. The distinction is consistent. A change in the price of the good results in movement along the existing curve. A change in any outside factor, like costs or competition, physically translates the entire curve. Differentiating between a simple price adjustment and a fundamental change in market conditions allows for a precise prediction of how supply will actually behave in the real world.